We discussed last meeting about the graphing linear inequality, that is to show the solution set. As we all know, set is a collection of well-defined objects. Now, in this case, we say when we say set of our solution set of a given inequality, it's that we're now providing what are the possible values. If it's conditional inequality, what are the possible values that would satisfy the inequality? And we know that there is a certain duration or certain period, and it goes to infinity. So what we need to do is that first is we just simply graph the given inequality, and after graphing, we are going to identify as to where is the solution by means of identifying the solution or the region where the inequality will be satisfied. In this case, our steps is that simply we will um, make the inequality equality. Afterwards, we will look for two solution of the equation as it was a changed equation, and afterwards, once we have the two solution, we will graph the inequality, and then once graph, we will use solid or dashed line. Solid for any inequality such as greater than or equal to, less than or equal to, and then broken line or dashed line if in case we are having an inequality operation of greater than or less than, implying that the line itself is not part of the solution, but it's the boundary from that point onward, but the point that the line is not included. And then once we were able to graph the line, now we will pick a test point, which the best test point we have is um, the 0, 0 coordinate or the origin. If it does satisfy the inequality, then therefore the region where the 0, 0 coordinate was located is the solution region. Otherwise, the other way around. Okay? Now, so much with the recapping of what happened or transpired last meeting. Our the next topic that we will have is we will have the so-called system of linear inequality. Okay, what is system of linear inequality? Okay, let's take a look at this example. Here we have system. Okay, we have the system of linear inequality. First, you have still the word here, uh, linear inequality. So it's an inequality which actually have a straight line, or it is from producing a line, a straight line. So when we say system, it refers to a collection of two or more linear inequality. Okay, so when we talk about system linear inequality, we are now trying to consider not just one inequality, but we are talking about a bunch of inequalities, at least two or more. So with that saying, our goal for this lesson is that we'll be able to graph the system of linear inequality, and at the same time, we are going to find the solution satisfying the system of linear inequality. Now, those were our objectives this morning. What we need to understand is that, of course, we already established the fact and how we are going to graph linear inequality. So there's nothing that we're going to change about it. We just simply graph all the linear inequalities available in our system, and then whenever it is available, we'll just simply show the solution for each system for each inequality, and then wherever the solution set, wherever the solution collides is where our solution of the system inequality. Because if it only satisfy one equation or one inequality, and it does not satisfy the other, then that means to say it's not the solution of the system. So what I'm trying to convince here is that for us to know whether this whether that region is a solution of inequality is that it must be shared. Okay, it must be shared among all other inequalities or among the inequalities in your given system. Now let's take a look at this example. An example of system of linear inequality, say for example, we have, okay, this is an example of system of linear inequality. Uh, as normally we will put it like this, implying that this is considered as one or as a system. So we're not taking each inequality at a time, but rather we're taking both. Okay, this is an example of system of linear inequality. So when it comes to system of linear inequality, we are going to solve this one by simply looking for an ordered pair. Simply I'm saying the value of x and y that both will satisfy the first inequality as much as the second inequality. Because if it only satisfies the first one, but this satisfies the second, it means to say that is not that is not a solution of the system of inequality. But of course, we do understand that when it comes to linear inequality, there is an infinite solution to a given inequality. No wonder that in our solution last time, we are showing the solution in terms of region, shading a region in our Cartesian plane upon graphing the inequality, because we know for a fact that the solution does not only limit from a certain point, but it actually goes beyond, or especially it depends upon the condition of our given inequality. Okay, now let's take a look at this one. Let's find the solution of this system. Okay, this is an example of system of linear inequality. We've got two equations here, or we've got two inequalities, and then we're gonna find the solution for this one. Now this will take a little bit, will take us a little time to show the solution because we have two inequalities already. So what do we need to do? First is the same with how we graph the linear inequality last time, which we will make each inequality into equation and then look for a solution that equation enable for us to graph. So first is we have x plus y greater than 2. First is we are going to make this into equation, making giving us now x plus y equals 2. Then the next thing we need to do is we will look for the value of y. We will look for an ordered pair that will satisfy this one. Just 2 because enough, 2 um, points is already enough to show the solution or to graph the inequality or the equality for this example situation. So first is I'm gonna use now, I make a assumption of x equals 0. And what must be my y when x is 0? And that is already what I call the y-intercept because I'm using intercepts. So this will become 0 plus y equals 2, giving me y equals 2. So to have it shared out together, then we have 0, 2. Guaranteed that 0, 2 is a solution of this equation. Another here, I'm going to let y also equals 0, so that means to say x plus 0 equals 2. Thus, I have x equals 2, making now 2, 0 as my x-intercept, while this is my y-intercept. See? So, these are the only points that when I have these 2 points already, I can graph already the first equation. But hold on, I still have the second one. So I need also to have this graph, look for a solution of this one so I can graph this as well. Because take note, we're now talking about system and not just one inequality. So let's take a look for the second. Let's say, of course, we have 2x minus y equals 3, making this into equation. Next, the next thing that I'm going to do, by the way, I introduce you here the so-called, uh, these are called the intercepts, but this time I'm going to use values that is not, because if I'm going to use the intercept, I'll have a non-whole number value, so I think it will be difficult for me to graph if I'm going to use fraction. So what I'm going to use to do now, I'm going to make an assumption of making, I'm going to let y equals 1. Okay? Y equals 1, and then I'm going to solve now this. So that's 2x minus 1 equals 3. So I have 2x equals 3 plus 1. 2x equals 4 divided by 2. So I have now here x equals 2. Okay? I have x equals 2. So that means to say my solution set, my solution is 2, 1. When x is 2, then y equals 1. Now let's have here for y. So I'm going to let x equal 0 still because I will have a whole number. So that will become 2 times 0 minus y equals 3. That is negative y equals 3 divided by negative 1. So I have now y equals negative 3. So my solution, my ordered pair is negative, or rather 0, negative 1, or negative 3. Okay, so I have now the solution for both. What I'm going to do is to graph this. Okay, first is, of course, our Cartesian plane is needed. So 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, first is I'm going to graph this. I have 0, 2. Okay, this one. And then I have also have 2 zeros, so this one also. Now, you have to go back to your inequality. What am I going to use since this is my inequality? I have to use broken line or solid line.
Broken, sir.
Broken line, sir.
Okay, I'm going to use a broken line or dash line because my inequality is not strict. By the way, we call it strict inequality and not so strict inequality. Strict in the sense that it includes the line. But if you say not strict inequality symbol, it implies that the line itself is not part of the solution. So since it is not strict, so I'm going to use a broken line. Okay, so I have now this for the first inequality. I'll just label this graph as x plus y greater than or equal to 2. Next that I will have to graph is this one. I have 2, 1. This is 2, this is 1 here, so this is the point. Afterwards, I will have to plot also 0, negative 3. 0, negative 3 is here. So now for the second inequality, what am I going to use? A solid line or a broken line?
Solid, sir.
Okay,
Solid
it's a solid
line.
line because we have a strict inequality. So I'm going to have to graph this one. Okay. I sorry, it should be solid. Okay, label this graph as 2x minus y less than or equal to 3. Now, the next thing that we have to do is we are going to test both inequality here with our test point. Now, in regard to this particular inequality here, x plus y greater than 2, I'll test this one with this is the origin. So I'm going to test whether the solution for this inequality, the broken one, is it going here or going there? So that's what we're going to check. So the 0, 0 is found below this line. So let's test. That is x plus y greater than or equal to 2. 0, 0 is my test point. So that is 0 plus 0 greater than or equal to 2. That is 0 greater than 2. True or false? Of course not. Therefore, the solution is not here for this inequality. The solution goes in this direction. Okay? That is for the first inequality. Now let's take a look for the second inequality. Of course, using this one, I'm going to test this one with the zero. This is my inequality. The zero, zero is found here. So it's either the solution is here or there. So that's going to be 2x minus y less than or equal to 3. Then my test point is 0, 0. So that's going to be 2 times 0 minus 0 less than or equal to 3. Basically, it is 0 less than or equal to 3. And of course, this is true that 0 is less than or equal to 3. Therefore, the solution of this one goes this direction. Okay? So if you notice now, this is the colliding section. If take note, both linear inequalities here are both arrow-headed, implying that it can be extended to infinity from this going to this direction and going to this direction as well. So you notice this is the colliding section. Okay? That's the colliding section. So if that is so, if we are going, although this is a solution here, this is only a solution for x plus y less than 2. But if I'm going to pick also this one, is only a solution of 2x minus y less than or equal to 3. If I'm going to pick this region here, of course, this is no solution at all to any of the inequality. But if I'm going to pick this area here, it will now surely will satisfy the system. It's now called, this area, the colliding section here, is our solution of the system. Now, just to prove you that that is a solution, let's take, this is 1, 2, 3, 4. I'm going to pick now for this coordinate here, which is 0, 4. Because surely it falls on the colliding section of our solution set. Now, let's test whether these will satisfy to both inequality. Otherwise, our answer is wrong. Okay, let's have to take a look at this one. Let's test. Now, we will check. So we have 0, 4 as our coordinate. Let's test it. X plus y greater than 2. So that's 0 plus 4 greater than 2, which is 4 greater than 2. Okay, we're on track. Because 4 is greater than 2. Now we still have one more inequality to prove that 0, 4, which is found in the solution section, is also a solution, that is indeed a solution of the system. So you have 2x minus y less than or equal to 3. So this is going to be 2 times 0 minus 4 less than or equal to 3. So this is going to be 0 minus 4 less than or equal to 3. Negative 4 is less than or equal to 3. Indeed, we're right on track because negative 4 is less than 3. Implying now that this coordinate 0, 4, which was found here in the colliding section of our solution set for both inequalities, which is now our system, so-called system, it implies that indeed this is our solution. If I'm going to remove these lines here, if you look at this one, so this is now our solution. From this point here, going there. Just make sure when you move this direction, when you move to this side here, this is your boundary or your limit. But at the same time, you know that the limit itself is not part of the solution. Now, when you move from this direction also, going up, you know this is the boundary. You cannot go down. You cannot move. It's like you are not permitted to go down here. You're not also permitted to go down here. You can just move upward going there. But of course, this line here, the broken line is not part of the solution. But on the other side here in this direction, the line itself is part of the solution. So if you happen to pick any coordinate somewhere here in this line, it will satisfy both. But if you're going to pick any point somewhere here, it will not satisfy both. It might only satisfy this system or this inequality, but does not satisfy this one because of the idea of the broken line. Okay, let's take a look and have one more example. And let's see where is or how do we go from there. Let's take a look at this example. Okay, I'll have to erase everything first. So now what we're going to do is we'll have another example and let's see. But this time, instead of having two inequalities in our system, let's try to extend it to three. Like I said, when it comes to system linear inequalities, we're talking about two or more inequalities put together and considered as one. So let's take a look at this particular instance here. Let's say we have x less than or equal to 2. I'm just going to use smaller numbers so that graphing later on is not that difficult. And then they have y is greater than or equal to 2x minus 1, for instance. And then another one is, let's say you have x minus 2y greater than, let's say, 2, for instance. So I've got here three equation or three inequalities considered as a system. So what do we do? Again, we will follow what we did earlier, is that we have to approach each inequality in our system as equation and then look for a solution of the equation, being able to graph them. And then afterwards, we will look for the solution for each inequality, and then we will look the colliding section. Sometimes it's possible that the system doesn't have any solution at all. Yeah, I mean, that situation happens whenever you graph the system, and then it so happened that the solution actually repel. They're not moving towards the same direction, but they're actually going towards opposite direction. So there's no way you're going to find any common section at all in your shaded, or at least the region where shared by both inequalities. So if that happens, it means to say that the system doesn't have a solution at all. Okay, that is what will happen. And especially for this one, since we have now three inequalities here, we're not just simply talking about a solution that will satisfy two, but rather a solution that will satisfy all the three. Okay, as for us to consider that solution, or that solution to be a solution of the system. Otherwise, it's not a solution of the system. Okay, so when we talk about solution of the system, simply we're talking about ordered pair, the value of x and y that will satisfy the system. Okay, and not just the inequality. Now let's take a look at this one first. Is, of course, I'm going to take this as equation, so that's x equals 2. By the way, this is a constant value, so that means to say this is actually a, all throughout your line, the value of x is the same. So that means to say we will end up having a vertical line, okay, a line that is parallel to the y-axis. Because no matter how much you change the value of y, still the value of x will remain as 2. Because our equation says here that we have x equals 2, or x equals constant. Now I'll have to take the second one. Y is greater than or equal to 2x minus 1. Okay, in this situation here, y is greater than or equal to 2x minus 1. Of course, we will look for a solution here. So what will happen? What will be my y when x equals 0? So that is y. Sorry, this must be equation. Because the first step is we will rewrite the equation, then equals into equation. So x equals 0, so this is going to be y equals 2 times 0 minus 1. We have y equals negative 1. So we have now x equal, or rather, our solution, the ordered pair here is 0, negative 1. And what must be the value of x when y is 0? In this case, I'm not going to use y equals 0. It's because my x will become fraction. So going away with the fraction, then I'm going to, looking back here, we have x equals 0. So let's take a look at y. For y, I will not use, or rather for x here, I will not use y equals 0, but rather I'm going to use y equals negative 1. Okay? I'm going to have negative 1, for example. So y equals negative 1, so this will become now negative 1 equals 2x minus 1. That's going to be, transpose that one here, that will become negative 1 plus 1 equals 2x. And this is 0 equals 2x divided by 2. So I have now x equals 0. Okay? So I have 0 and negative. Sorry, what am I doing? I am just solving the same term. Sorry, sorry. We have already y equals negative 1. I should have skipped for negative 1. We have already this value. Let's take a look at positive 1. Let's have positive 1. So this is going to be positive 1. This is going to be positive. So this is going to be 2. So this is going to be positive 1. So our solution here will become 1, 1. Okay? Yeah, yeah. Am I correct? Okay. I have already the coordinates. And let's go down to the last one. We have x minus 2y equals 2. So with that saying, x minus 2y equals 2, I will now, or let's say x equals 0. At x equals 0, my y is 0 minus 2y equals 2. So it's negative 2y equals 2 divided by negative 2, have y equals negative 1. So we have now 0, negative 1 also. And then for the next one, for the y value or for the x axis, so I'm going to use here, let's say y equals 0. At y equals 0, what must be my x? So that is going to be x minus 2 times 0 equals 2. So that is x minus 0 equals 2, x equals 2. So I have now 2, negative 1. So these are my values. So I have already plotted or my necessary information to be able to graph the system. So first, okay, I have here our Cartesian plane. So I'll graph first this one. I said this is a x equals constant. So when you have x equals constant, our graph is vertical line parallel to the y-axis. By the way, this is x-axis and this is the y-axis. So meaning to say when we have in an x equals constant, our graph is actually similar to this one, wherever you find this one. So first as we will plot this one, this is x 0 or rather 2, 0. We will locate that coordinate which is this one. Now following our symbol of inequality, it should be solid and we will draw a vertical line. A solid vertical. So we plotted already and graphed the first inequality in our system. Inequality in our Cartesian plane. So I have it this graph. This is x less than or equal to 2. Now the next that I'm going to graph is the second inequality, which is y greater than or equal to 2x minus 1. So I have here 0, negative 1, that is 0, negative, or rather this is 0, negative 1, this is the coordinate. And then next is 1, 1. This is 1, 1, positive 1, positive 1. So again, my inequality is still solid because my symbol of inequality here is still strict. So what I'm going to do is graph here the line. The line is not straight. Okay, so I have now this line is y greater than or equal to 2x minus 1. So after this one, I'll have to grab the last one, the last mark. So that is going to be 0, negative 1. That is 0, negative 1, this line, or this coordinate. That's the same with this one. Then followed by 2, negative 1. 2, negative 1. So here. Wait, that's 2. No, this is 2, negative 1 here. 2x is, sorry, the x is 2, positive 2. And then y is negative 1. So this one. Wait, what happened to my line? First is 0, negative 1. 0, negative 1 is this. And
Excuse
then
me,
is
sir.
anything wrong
Kanang sa 2, negative 1, sir, ba kay dili na 0 kay ang y is equal to 0 man ang gigamit.
here?
Oh,
Ah, yeah, this is 0, negative 1. That's why I said it is weird. Ah, sorry. This is 2, 0, right? Because y is 0. That's why it is not, it doesn't make sense. That is 2, 0. So it's 2 and then y is 0. So this one. And then I have to use a broken line. It's because the line is not part, or we're using here a non-strict equality. Okay. So there you go. Afterwards is we will test now each line. Where are their solutions set? Let's start with this one. Of course, testing this x, or I should say x less than or equal to 2. Let's test with 0, 0. That's going to be 0 less than or equal to 2. True or false? Indeed, it's true. So if it's true, therefore this line, the solution goes this direction. Okay, going here. Okay. For the second inequality, this one, y greater than or equal to 2x minus 1, that is a 0, 0, what will happen? That's 0 greater than or equal to 2 times 0 minus 1, that is 0 greater than or equal to negative 1. True or false? True also, that 0 is greater than or equal to negative 1. So therefore, the solution for the second line for this line is going up here, including this part. Okay. Next is we'll have x minus 2y greater than 2. So this is going to be at 0, 0. That's going to be 0 minus 2 times 0 greater than 2, which is 0 greater than 2. It follows that the solution is false. Okay, not true. Therefore, the solution for this line, the broken line, goes down. So it goes here. So where is now the colliding section of the three? So if we look at this one, this line goes here. Well, this line goes up here. And then this one goes down here. So it follows that this is the colliding section, this area, right? Okay, let us erase the rest. So this is our solution area. Let's see. Okay, this one goes here. Okay, of course, this part of the solution to be shaded. While this one goes down here, so this is part. While this one goes this direction, so this is shaded. Okay, this is our solution set. Here, this is the solution of the system. Okay, we've got the solution of the system. Now let's just test, pick and coordinate here. Although I cannot assure you what must be the value here. If this is 1, 2, 3, 4, let's say consider using 5, or no, rather 10. Let's say this is 10, y 10. The value of y is 10. And then let's see whether, let's try to consider a value of 5 here. So let's test 5, negative 5, negative 10. As I'm sure that negative 5 and positive 10 is somewhere in this region, hopefully, because our graph is not precise, but I'm just looking forward that this coordinate 5, -10 is one of these shaded area here. Now let's test this one, whether it will satisfy these three. Okay, let's check. So that's going to be -5 and -10. So that's x less than or equal to 2. Our x is negative, so that's -5 less than or equal to 2. Correct? Followed by, let's test the second one. Y is greater than or equal to 2x minus 1. So that is -10 is greater than or equal to 2 times -5 minus 1. That's -10 is greater than or equal to -10 minus 1. -10 is greater than or equal to -11. It's true also because -10 is greater than -11. Now let's test the last one. Hopefully this will satisfy the last. X minus 2y greater than 2. So that's going to be -5 minus 2 times -10 greater than 2. So it's going to be -5 plus 10 greater than 2, which is +5 greater than 2. It's also correct. It follows that indeed, this is one of the solution which actually found in this area. Okay? So you have any question or clarification about this situation here? Hello? Do you have any question? You can ask question now. So if we will recall or recap now the steps in finding the solution of the system, first step is, of course, when we talk about system, then it includes two or more linear inequalities considered as one. And to solve the solution for that one is first, we will write each inequalities in the system into equation, and then we will graph each inequality, and then we will locate the solution, the region for the solution of each inequality, and then look for the colliding section. And then wherever is the colliding section, then that is the solution of the system. If we can find one, that means to say the system doesn't have any solution at all. If it doesn't have a solution, it means to say that there is no single ordered pair that will satisfy all the inequalities in your system. Again, do you have any question or
Nakikamay,
clarification?
nakikamay
Yes,
question, sir.
yes,
If,
Mr. Peralta.
what if, sir, kung dili gid makover sa tanan ang kwan, sir, dili gid makuan sa solution of the system, sir, unsa ibutang ana, sir?
What do you mean cannot be covered?
What if, sir, dili makover tanan, sir, ba kanang finding the solution system, sir, ba iyahang pag-cover sa kaning three types, sir, ba dili naiusa ka buok nga dili siya makuha, sir. Unsa ibutang ana, sir?
No, no. If example, if there are three inequalities, and then so happen that there is a colliding section for the two, but the other one is going opposite direction and not even sharing any solution to the rest, it means to say that the system still doesn't have any solution at all. Because the condition for the system to have the condition for an ordered pair to be a solution of the system, it should satisfy all three or all the inequalities in the system. Otherwise, if it cannot satisfy or if it doesn't satisfy all the inequalities in the system, then it means to say that is not a solution.